Good morning, afternoon, and evening. It is my pleasure to be here at the Data Platform Summit 2022 to talk about the two-pronged approach to securing sensitive data on Azure SQL databases, leveraging dynamic data masking and row-level security. Special thanks to Microsoft for supporting Data Platform Geeks and SQL Server Geeks community initiatives. A little bit about me. My name is Sohini Garg. I help organizations build a robust and scalable data estates to leverage for strategic decisions and optimal operations. I am passionate about data architecture, integration, and security. My expertise includes cloud adoption with Azure technologies, Oracle and SQL Server databases, modern data warehouses with Azure, data catalog, etc. I have my LinkedIn URL over here. I would love to connect with folks. Here is an overview of what we plan to cover today. We would first look into the need for row-level security and dynamic data masking, an overview of row-level security, also known as RLS, a demo of row-level security in a table whose schema can be altered to a security predicate column, an interesting scenario. This table has secure records, which should be only visible to certain authorized folks, and open records that everybody who has access to that table should be able to read. And our security policy will handle both and deliver the appropriate records. A demo of a row-level security in a table whose schema cannot be altered. Security is driven by a related lookup table, and we have the same interesting scenario. This table has secure records, which should be visible to only certain people, open records, which should be visible to everyone having read access on that table, and the security policy will handle that. An overview of dynamic data masking, and finally, a demo of dynamic data masking enabled for these above tables, and we will see it all come together with both capabilities leveraged. What is the need for row-level security and dynamic data masking? In today's organizations, leveraging data is key for operational efficiency and competitive advantage. However, there is also a heightened risk nowadays of the same data falling into the wrong hands through unauthorized access. According to the IBM Cost of a Data Breach 2022 report, the cost of a data breach averaged $4.35 million in 2022. I have put a link for the source, this particular report, over here in my PowerPoint report, and you should be able to view it. So it is important to have a strong security framework to maintain data security. While authentication, authorization, SQL Server, firewall rules, etc. should be used to secure access to SQL databases and objects, row-level security and dynamic data masking are two additional capabilities we could add to our security framework for secure tables to make it even more resilient. Column-level security is out of scope for this particular presentation. What are the advantages of leveraging row-level security and dynamic data masking? As the data is secured through fine-grained access control, common datasets can be queried directly by stakeholders for analytics. Data stakeholders in different roles can only access authorized data applicable to them, as we can control secure access at a granular level. Effective and scalable data access management, especially as we do not have to create multiple versions of the same data. That's a great option for our administrators who have to manage the access management. This also streamlines the implementation of single source of truth through enterprise datasets and enable data democratization. It helps us achieve the balance of data access and data security. Row-level security on Azure SQL databases. It's a way to implement security policies at the source, which controls access to rows in the schema-bound tables. It's a predicate or condition-based access control that works on the database tier itself, applying a security predicate or condition to all queries on the table. The predicate determines which rows of the table a role or a user can read. There are two types of security predicates. The filter predicate silently filters read operations, that is, select, update, and delete operation, to exclude rows that do not satisfy the predicate. The user does not get an error and is not aware that rows have been filtered for them. Block predicates, on the other hand, explicitly block write operations, that is, insert, update, and delete operations that do not satisfy the predicate fail with an error. Block predicates aren't currently supported in Azure Synapse, and we will not be discussing this capability today. Here is an example of row-level security. The table DBO persons has 13 rows of data. However, as row-level security is implemented on it, the user named math.depth_head can read only a subset of the rows they have access to. Here's an example where I have executed the query as math.depth_head, and the bottom part is the query results, and they get only 6 rows of data back. The rest of them are filtered for them. They do not get an error, but at the same time, they only get the 6 rows that they are authorized to view. It is implemented at the database layer, so it is seamless. Math.depth_head would not even know that some rows were invisible to them. What are the parts of implementing row-level security? First, there's the predicate function, a user-defined table-valued function that contains the filter predicate bound to the table. It contains the security logic that will be used to filter rows. The security policy that is bound to this predicate function, it contains filter predicate tying the security policy to the predicate function. It binds the security predicates to multiple or applicable tables. In fact, there can be multiple predicates in a security policy that could be applicable to different tables in the database. And finally, a select permission has to be given on the predicate function to database roles or users who need to be able to at least select a subset of rows from that secure table. What are the effects of the filter predicate? The application or user is unaware that rows have been filtered out. There are no errors. It affects all get operations. Filtered rows cannot be selected, updated, or deleted. One can insert rows of data that would satisfy the filter criteria later and be invisible for that same user in a subsequent select operation. A security policy with a filter predicate applies to even DBO users, that is the database owner user. That's key. And the DBO owner roles. So even if a database owner user queries a table with a security policy enabled, the rows will be filtered by the database as defined by the security policy. As the database engine has to execute the predicate function for every role selected from the row-level security enabled table, make sure to optimize the function's code for performance and index any appropriate underlying columns. Here are some security notes to keep in mind about side channel attacks. A malicious security policy manager who has sufficient privileges can still perform data exfiltration. To minimize risk, always grant permissions to users, keeping in mind the principle of least privilege. Audit changes to security policies regularly to see any unusual activities. And keep in mind, carefully crafted queries can be used by malicious users who have some familiarity with the dataset to deduce data. For example, if Kathy's salary in the SAL table is 175,000, they can run a select statement like this, which says select 1 divided by 175,000 minus salary from SAL table where emp name is Kathy. Now this would give a divide by zero error, even though they don't have the ability to read that row necessarily. Now, given that the query returns a divide by zero exception, even though RLS is defined on the table, the user can deduce the salary of Kathy. Well, it's demo time now. Let's hop over to the SQL database to set up row-level security on a table. And let's see the security policy enforce row-level security on that schema-bound table. So I have logged into SQL Server Management Studio. Here is a script named DPS2 pronged security demo script. In this, we assume that the tables, database users and roles have already been created in the database. And we will start working with this to implement row-level security and dynamic data masking. There is a separate script, both of these scripts, this one as well as a complete setup, walkthrough, and cleanup script. Both of these resources will be available at the data platform website for your reference later. In operational real-world databases, it is best practices to use Azure Active Directory users and groups to log into the SQL database so that it's a passwordless authentication. In fact, even multi-factor authentication is encouraged. So it's better to use that rather than SQL Server authentication. However, in this case, we are using SQL authentication just for demo or test purposes so that it's simple. I am logged in as admin JAHAJ, which is the administrative user or the database administrator. The database users have already been assigned database roles. There are 4 database users that we are concerned about. One is, think about this scenario as a university. There is Principal Gupta, who should be able to read all of the information, all of the rows at least, whether it's master and mass, that's a different question. She has been granted read all role, which will be used later on to grant the ability to read all the records in the persons table. The math dept head, or the math department head, has been granted read teacher math role, which will be used to have the ability to read math rows marked in the persons table, and it would be marked with read teacher math in them, so those rows. And we will look at the data in a little bit. And then there is art department head, who has been granted the read teacher art role. There's a typo over here, let me correct that real quick, which would be used to have the ability to read the read teacher art marked rows in person table. And finally, there's an individual user. You can think of them as a student who's group user 1, who is not assigned to a role and will be able to see only their own record. For the first demo of row-level security, we have a table named DBO persons with data to read. This table's security, this table's schema originally just had person ID, name, person type, SSN for social security number, phone number, and email address. But this table's schema could be altered for purposes of implementing row-level security to have a view role column, which contains the name of the specific database roles which can view specific records in the DBO persons table. And one other thing to keep in mind, it is always best practices and easier to manage or scalable management of access control if you grant access to users through roles. That is why I have already set up these roles from before so that we follow some best practices in terms of granting security. So this table has already been created before. I'm logged in as the database owner, but let me baseline the table's data. Note that none of the rows are masked as at present. So here we go. We have 13 rows. Let's look at them one by one real quick. There's Renu Gupta, who is the principal. Her social security number is 111. We have her email address. Note that her email address has a domain of .gov for later on purposes for dynamic data masking. And in this particular case, only Renu, a role that has read all privileges should be able to read Renu Gupta's row. Edward DeJean is a student, and they have a .com domain. Their row should only be read by the math teacher, the read teacher math. And likewise, all the way down till row 10, there are specific rows who should be able to read that row. Now, Hema Keskar is a student, row number 11. They have an edu domain for the user email address, and their row should be read by group 1 user 1, and in addition, anybody who has read all role. And then finally, I did mention in our slides that based on my experience on a previous project, we had a certain table which needed to have certain rows restricted to certain people or certain roles within the database. However, that same table also contained rows that should be able to be read by everybody who has select access on that table. And we had found a way to have the security policy work for having the security so that we can set up the security policy for the open rows to be read by everybody, and then the specific rows that are locked to be viewed only by the people who have explicit authorization on them. So these rows 12 and 13, Open Data 1 and Open Data 2, are having the view role as null, which we're going to see later how it's utilized. But this is the data in the table. Let me first baseline the table's data just to make sure that all 4 users can read every row from the table DBO persons. This is a brand new table. Row level security has not been enabled on it, so everyone who has select privileges on it should be able to see all the rows. Previously, to set up these users, Principal Gupta, Math Depth Head, Art Depth Head, and Group 1 User 1, I have granted them to a reader role so that they can read rows from DBO persons fixed struct, and the lookup table DBO lookup persons fixed struct secure. So here I am. Let me make sure execute and see how many rows Principal Gupta can see. I'm going to scroll down for both tables. They can see all 13 rows. And similarly for the second table, DBO person's fixed struct. Principal Gupta can see all 13 rows for both tables. Let me double check for math depth head. Again, 13 rows. Rows for the second table as well. So we have verified that all 4 users are able to see all 13 rows of both tables. Before we start configuration for row level security, let's think about a little bit about what is our expectations about who would be able to read which of these rows. So the way I've set up this table, read all, the rows with read all would only be readable by the person with a read all role. In this particular scenario, Principal Gupta was assigned the read all database role. Any row marked with read teacher math will be only readable by the person with the read teacher math role, who is the math depth head. Any row that has read teacher art would only be readable by the person with the read teacher art role, the art depth head. And finally, any row that's marked with group 1 user 1 would be able to be read by group 1 user 1. And lastly, any row that's marked with null, we had discussed earlier, are open data. So they should be visible by everybody. So all 4 users should be able to read these open data rows. That's something that's going to be taken care of by our security policy. And last final thing, let me add on that the read all role, the way our security policy will work, is the read all role can read every row in this table, all 13 rows. So in keeping with best practices, I'm going to create a security schema to house all our security predicates, function, and the security policy. So I am going to go ahead and create the security schema. There you go. It's been created. The next step is to create the function that is going to contain the logic for who would be able to read rows. Now, keep in mind that this is for tables whose schema could be altered by a column view role in this example, and that is the DBO persons table. The statement goes create or alter the security function, and because the person ID for the table is the primary key, I'm going to drive the logic through the person ID column. So the security policy is going to pass the person ID value from the row as a parameter to the security function to check whether the person has the ability to select that row. So that's what this variable is for, to pass in the person ID value from the row. It returns a table with schema binding, and here is the logic. If this function returns a row back to the security policy, that means that the person has the ability to select that row. So the logic here is we select person ID from DBO persons, and here is where the logic begins. This first part is for the rows that actually are secure, that are not open. So the logic goes for the function is first find out whether this person has access to the secure row, if it is a secure row. And with that, I'm going to union. This latter part is for any open data rows. So in case it is an open data row, then it's going to pass back as true so that a user can read an open data row. So person ID is, the value of person ID is what is going to drive the security of a particular row. The security policy is going to pass the value of that particular person ID in that row to see whether the person who's trying to query the data has access to it. So let me quickly run DBO persons so that we can compare the data and think about the logic. So when a person queries select star from DBO persons, the security policy sends in rows by one by one. And based on the person ID passed in, the function first detects the row based on this person ID passed in. And let's say it's row number 2. When it sees that, it first reads the view role value from that row, which is read teacher math. And it checks whether the current user belongs to the database role that is read teacher math. If it is, if it is yes, isMember is a SQL function that finds out whether the person who's trying to execute this query belongs to the role that's passed in as the parameter to it. So because it's passing read teacher math as the value, it's finding out whether the person belongs to read teacher math. Or is the person a member of the read all role? Does the whoever's trying to execute, does it belong to the read all role? Or is it a member of DBO owner? Note, I have explicitly granted DBO owner permissions to these all particular rows. Unless the DB owner role is explicitly granted access to a table, the best part about the security policy is, the DBO owners would not have access to the rows unless they were explicitly granted rows here, or unless they were in one of these roles. And then finally, if they don't belong to any of these rows, now this is to handle this particular row. If a single user, if you see the view role value, is that person's username group 1 user 1? Then the security policy would allow us to select that particular row. So as long as any part of this is evaluating to true, that means the person has access to that particular row. And then, as this is an OR condition, if any of these are satisfied, it would be true. And lastly, we had talked about the open data rows. What happens if it's an open data row? Because, the view role would be null. It would not satisfy any of these conditions because it's null. That's where this last part comes in. It tries to, assuming it's the same, or, it would have been false for this part. However, it's trying to find out the person ID as open data where person ID is equal to person ID, and is the value of view role null. In that case, a person has access to this row. So this was evaluate to true for every single user who's trying to execute a select query on this table. But these particular rows would only be visible by people who belong to these particular rows respectively. So that's the first part. We created the security function. As long as any of these return as true for that particular row, a person has access to it. And then we've created the security function, but now we create the security policy. That is the piece that has the filter predicate on DBO persons using that function that we had created previously. So what I say is create the security policy, add the filter predicate referring to the function that we had used before or created before, and we pass in the person ID of the DBO persons table record that's being queried. And we need to put the state on so that the security policy is enabled. And as soon as that is done, then the security policy is tied to the security function, and both would work in conjunction to enable the security on the table. Now, if we want to disable the security policy temporarily, we can alter the security and set the policy to off. So let me go ahead and create the function and the security policy real quick. The function's been created, and so has the security policy. The security policy, as we discussed, is tied to the security function. I'm going to refresh, and real quick, I'm going to check the function. It's a table valued function. There, security function SP person, and let me double check that the security policy has been created as well. Yes, indeed. All right. Let's make sure we also, one of the steps is people need to have access to select from the security function to make sure that the security logic is applied. So I grant select on the security function. And now it's time for us to test. I'm first going to execute as Principal Gupta. Keep in mind, actually, let me baseline real quick. I am logged in as the DBO owner, and let me select DBO persons again. It's always good to look at our data before executing as somebody else, just to make sure that there are, the DBO owner was granted specific permissions to see the row. That is why I'm seeing all 13 rows. Now let's execute as Principal Gupta, who belongs to the read all row. There you go. Principal Gupta is able to see all the rows, including the open data rows as well as the secure rows. Now let's execute as Math Department Head. Let's first think about which rows we expect Math Department Head to see. The Read Teacher Math, because that's their role. Read Teacher Math, row 5, row 2, row 8, row 9, and then the open data rows 12 and 13. Let's double check. There you go, 2, 5, 8, 9, 12, and 13. So they are able to see all the Read Teacher Math rows and the open data rows. Similarly, let's try Art Department Head, Read Teacher Art, and then the open data rows. And let me execute as myself again, the owner, just so that we can see which rows Group 1 User 1 should see. They should only see row 11, 12, and 13. Let's double check. There you go, 11, 12, 13. That brings to an end to the first scenario. Now let's go to the second scenario. So we have DBO persons fixed structure, which has the same person ID, name, person type, social security, phone number, email address. Note, we do not have view role in there, but we have now a lookup table that has already been created that has the same person ID, but person ID and related person ID is what ties these two tables together. And then the role is actually defined as an additional column in the lookup table. And that is what drives the security for this particular table, DBO persons fixed structure. So just let's make sure first I'm logged in as the owner, and I am selecting all rows from here. If you notice, there is, that view role is not in there. And here is the lookup table that has all the same related person IDs and the view roles. And let me join just so that I can see that we have the person IDs over here and the view roles over here, because it's joined on fixed person ID is equal to lookup related person ID. And that's how we see this row. Just as before, in case you were first creating that security policy and the security function, you would have created the schema. However, we have already created it in the previous step, so we do not need to do that again. And now we go into the security function. Just like the previous scenario, we pass, the security policy passes the person ID as a parameter. And I think the only difference over here is instead of just going against the one table DBO persons, it is going against lookup, the lookup table and the fixed structure table. So DBO persons fixed structure is the person table, and DBO persons fixed structure secure is the lookup table that has the roles identified. I'm joining on person ID is equal to lookup related person ID, so that it's the one-to-one correspondence and we get the correct row back. And just like the function before, we view whether, for a certain row, if a person is selecting, let's say, row number 3, trying to select row number 3, am I a member of Read Teacher Art? Or do I belong to the Read All database role? Or do I belong to the DB owner? I have explicitly granted DB owner permissions to read that table. And just like before, for the open data rows, I'm just making sure that if it's null, that we are able to select those as well. Now, one thing to keep in mind, previously I had done just a join, but I wanted to show you that we still have open data rows in DBO fixed structure. So I've done a left outer join. The key for this particular strategy is that the rows that are open data rows, they do not need to be in DBO lookup persons fixed structure secure. Because their roles are null, we don't need an entry for them over there. So the left outer join just for the select shows us that there's still data in the main DBO persons fixed structure for the open data rows, but it's not, we didn't have to add rows for the lookup table. Now, let's make sure that I run the script for the function. And I'm going to double check that the function has indeed been created. There, function SP persons fixed structure. We need to grant select privileges on the function for everybody. And then finally, we create the security policy just like before. Again, this one has a new name, person table fixed structure. The security policy would still pass the person ID of the row as a parameter, and we would have the state on, schema binding on, which is generally the default. And there you go. I am going to select both of these just to see comparatively whether we are able to see all rows or not. I'm going to first execute as the DB owner. Remember, we have been given explicitly permissions to read because I'm part of the DB owner. I'm able to see all 13 rows. DBO persons earlier as well as DBO persons fixed structure. And I've just put it in for comparison's sake, both of them. Principal Gupta, remember, was part of the read all role. So they are able to still see 13 rows in the DBO persons table, as well as 13 rows in the DBO persons fixed structure table. One good point about having this lookup table is, general users would not be able to see the value of view role, which drives our security. So that adds a layer of obfuscation for the end users. I don't think we need to expose how we are enabling security to everybody. So that's also a good point about this way. And let's execute as math department head. In both scenarios, they're able to see only the rows that are read teacher math. They are the same for the DBO person's fixed structure and auth department head. Let's double check. We're comparing, it's exactly the same rows. They're able to see the secure data as well as the open data. And finally, group 1, user 1. Able to see 3 rows each. This brings us back to the completion of the row-level security demo. Now that the demo of row-level security is done, let's hop on over to dynamic data masking. This again can be enabled on Azure SQL databases, SQL managed instances, Azure Synapse Analytics, etc. What is dynamic data masking? It's a process to obfuscate or limit sensitive data exposure by masking or obfuscating designated columns to users who have not been given access to unmasked data. So for example, if I have a table which has data in a column which I am masking, if the data looks like this, 076678990, a general user, when they select star from that table for that particular row, based on the format of the masking, they would only see obfuscated data. They would not be able to see the real data behind it. Data owners can designate how much of the sensitive data to reveal and to whom. So the DBO owner or the database owner or the administrator would set up the masking function which will drive how much of the data is exposed. Do note that the core data in the database is not changed. This is just a form of data obfuscation. So any of your queries, any of your where conditions, any of your pipelines and processes will run just fine, assuming they have access to the data, and they would, those identities that they run as should have access to the unmasked data, and they can run fine doing calculations, etc. Dynamic data masking is done inside the SQL Server. So regardless of any, what query tool you are using, the data would always be masked based on the criteria that was put in place. It is done on the fly, so no data is actually changed on the disk. So the data that we have on the disk remains. As a result, join operations and where conditions on the masked columns work just as expected. And they are also flexible. Standard database privileges can be utilized to define who can and who cannot see the data. Again, row-level security is, role-based access is best to manage and easier to manage. There are 3 parts for dynamic data masking. The data masking policy, that determines who can see the unmasked data. The dynamic data masking policy rules determine which columns in a database table are masked. The functions, the policy function itself, are methods to control the exposure of data for different scenarios. Example, if it's a default or a credit card or custom text, etc. This determines how much of the data in the column is obfuscated, in what way, and what, if anything, is shown to the normal user. What do different groups see? Users with administrator privileges can see all data as unmasked. So anybody who has database owner privileges like DBAs, they will be able to see unmasked data. Keep in mind, this is a little bit different than row-level security. We had to explicitly grant database owners the access to see secure rows on tables that have row-level security enabled. By default, everyone else sees the data as masked. One can control and limit access to unmasked data with Azure SQL database privileges granted to specific roles. And one also has granular level control to deny or grant unmasked permissions at the schema level, table level, or column level to a role, giving administrators granular control. What is masked and what are the masking rules? each rule defines the designated field to be masked and the masking function that would be used to mask the data. And each field that needs to be masked is defined using the database schema, table, and column name. Here is an example of how dynamic data masking works. In this example, all columns other than the first name are masked. So this particular table has first name, last name, age, phone number, email, and social security number. The database administrator has enabled masking on all columns other than first name. So as a result, administrators can still see unmasked data. That is, by default, administrators would still be able to see unmasked data. However, other users can only see the last name, the phone number, email, and social security number in the masked format. It's mostly obfuscated, and only the parts determined by the masking policy is shown to the end user. Azure SQL allows us different ways the masking functions help us control how the masked data is visible to normal users who do not have unmasked access. So the different formats for masking functions by default are, if it's credit card, by default everything is XXX except for the last 4 digits. If it's an email, you would see just the first letter and everything else is XXX, and it appends a .com domain at the end by default. A random number allows you to, it's normally on numeric columns only. A random numbers would generate a random number between the selected boundaries. You give the minimum or the maximum, and it would return a random number between those two parameters. And finally, the custom text is the most flexible. It allows you to define how much of the prefix you want the end user to see. What are the padded strings? Do you want it XXX or stars, or what else do you want to see? The part that's actually obfuscated. And the suffix if you want anybody to see any of the latter or the trailing part of that string. This custom text is also only on text fields. If you don't want, you can completely have padding string with no prefix or suffix, so you have complete control over that. And by default, there's also a way you can say the masking function that I'm using is just default. So on string, if you don't have, by default, your masked data will show XXX. Your numerics will show as 0. Your date and time, any date and time or date columns would show 1/1900, and any binary columns would show 0. Things to keep in mind. Dynamic data masking is applied on tables and any views that are based on those tables automatically. So, as the views inherit the maskings, you do not have to define separate masking on the views. So you can have consistency. Dynamic data masking is applied according to rules and permissions when we select into or insert into from that masked table. So if you select from table T1 into table T2, and you are a normal user who cannot see any unmasked data, if you insert into table T2 from table T1, all the data inserted there would be masked, so you cannot see the actual underlying data. Data that is exported into Excel or CSV from masked columns still stay masked. And masked columns can be part of joins and where conditions, and the logic works just fine because the underlying data has not been changed. The caveats to keep in mind: the only function available for date columns is the default function, and it always shows the date as 1/1900 to users who do not have access to unmasked data. The default email function is always set to .com, irrespective of what the domain of the email address is. So for example, if my email address is sohini.garg@vcu.edu, if my email was in that table where the column of the email is masked, my email would come out as xxx@xxx.com. So it would not show us the edu domain. In most scenarios, many people would not need to verify the domain. However, if you have a scenario where you are showing part of the email address to your customer service representative to be validated, instead of having the default function, you can use the custom text function to have granular control about, what is the part that you want what is the part that a normal user can see and what domain name they can see. Queries where joined and where conditions, they can still filter rows based upon the masked columns. So keep in mind that people who are having some knowledge of the underlying data can still deduce data if they have select privileges on them. Let's hop over to our SQL Server database again for a demo of dynamic data masking. All right, we are going to work with the same tables, DBO persons and DBO persons fixed structure. Let me do a real select to do a baseline quickly. Keep in mind I'm logged in as the database owner. See, all the columns are unmasked over here, right? As a baseline. Now I'm also the DBO owner, so I would have anyway seen everything is unmasked. But just a baseline. If you like, I will execute as Principal Gupta also, just to baseline it. Look at that. Principal Gupta is seeing everything as unmasked. Now we are going to do some masking. For Social Security, for DBO persons, I'm going to add a masking function, which is the custom function. It starts with partial, and what it says is on the leading parts, I'm going to just show the first 0, and nothing I'm going to show in the leading parts, and I'm only going to show the last pieces of the Social Security number to the person. Now, email address, note I did not put the default as a function. I wanted the customer to be able to validate the domain of the email address. So as a result, I'm using the partial function again. I'm going to show the last few characters of the actual email and the first few characters of the actual email. So this partial function, what it does is show the first few characters. The middle part, I'm going to just show it as stars, and the last part I'm going to show again. And phone number, I'm going to do for DBO persons as default. Keep in mind that the phone number is a numeric column. So as default, it's only going to show 0 for everybody. There, phone number is a numeric 180, so even though it's a big old number over here, it's going to show as 0. That's the expected result. Similarly, for DBO persons fixed structure, I altered the column to have the similar masking function as DBO persons. For email address, I have the same. Just for grins, I can change it to 7, just to show a little bit more. And for phone number, in this particular case, rather than doing the default, I'm putting the random function, where it's going to generate a random number between 10,000 and 18,000. Again, this is a numeric column. So let me apply those. All right, the masking has been applied. Now, finally, I want to make sure that, there are certain roles that I want them to have the ability to see unmasked data. So I'm going to grant unmask to DBO persons on the email address only to the read all role. So Principal Gupta, as he is or as she is part of the read all row, she should be able to see the email address for DBO persons as unmasked. And similarly, email address of DBO persons fixed structure as unmasked. Let's say Principal Gupta needs to send emails to all the students, so that way they can send emails to them. And for administrators, there is a script that allows us to see which columns have dynamic data masking enabled. So here is a script that uses sys masked columns and sys tables to verify which tables have maskings enabled for them. So as we had done before, there are 3 columns on DBO persons masked with these functions, and there are 3 columns on DBO persons fixed structure that are masked with these functions. Now let's see, our row level security is still enabled. Let's see what kind of data our users see with row level security and dynamic data masking enabled. Keep in mind, Principal Gupta has some special privileges granted to see the email addresses of students from persons and persons fixed structure as part of the read all role that she belongs to. As a result, she can see unmasked data for email addresses, but she does not have any special privileges for these other columns. So let's double check as Principal Gupta. There, social security number is masked. It's the beginning of it is masked completely. If you see, none of it, because it's starting with 0, that means none of it should be visible to anybody. It's padded with stars in the middle, and you just see the last 5, which is the 4 numbers and the dash. The phone number, because it's a default, given that it's a numeric field, we just see 0 in DBO persons. And then Principal Gupta has special privileges on email address, so they're able to see that. On this other table, the fixed structure table, you see social security number the same because the masking is the same. However, phone number is a random between 10,000 and 18,000. So you're seeing Principal Gupta sees random numbers for the phone number. And again, they're able to see email addresses because they have special privileges by unmask. Now let's execute as math head. Now math department head does not have any special privileges. So they are seeing social security number masked, phone number masked is random 0, default 0. Email addresses are masked, just like the masking was in the statement, which is email address, you see just the last 6. But note, because I did not use the default function, I'm able to see the last 6 digits. So if somebody, this is a scenario where if you wanted the customer service representative to validate the email address of the customer to make sure that they have the right one, this is one way to partially unmask some of that data so that they can validate it. On fixed structure, social security number is masked with just the last 5 being shown. Then the phone number is a random number, and then email is masked as well. And they still continue to see only the rows that they have access to, the read teacher math and the null, which is the open data rows. Let's double check as art department head. It's the same. See just the reader art rows, read teacher art. Social security is masked, phone number is masked, email address is masked in both tables. And finally is group 1 user 1, execute as user 1, group 1 user 1. I still see just the 3 rows and then my data is masked. So here you go. There are 2 levels of security working in conjunction together, 2 layers of security to make the data secure. Now what happens if I'm trying to trick the masking system and I'm just trying to do a substring of email address to see, whether I can see part of the data? However, if I execute as the art department head, there, trying a substring will not help me find out any part of the data. So even there's no way for us to bypass the security. And let me I think we've already done that, but let me double check and make sure that group 1 user 1 we had also executed. So that brings us to the end of the demo. I have included as part of my last slide some resources for reference. So I invite you to try and look at some of the links that I have included for documentation. Thank you so much for your time and your attention. It was such a pleasure presenting to you. If you have any questions at all, please feel free to reach out to me. Yes, feel free to send me an email and I'll be happy to answer any questions you may have. Once again, thank you so much for attending this session with me. It is such a pleasure. I hope you'll have a great day.